All right, we're back. We are on page 6 of Calc AB Notes 2. We're primarily talking about the chain rule. What we're going to do now is a problem that, as we go through the problem, when we get to part E, you might find it pretty tricky, and it depends on how much you remember from last year. And that's okay, because I'm going to walk you through it, and I will point out the parts that you definitely need to understand, and then the parts that as we go through this course, it'll become a lot clearer what we're doing. So this is a problem that we can do. It's accessible, but it's going to be a challenge when we get to the end. So let's take a look at it. It's really similar to questions that have been on the AP exam recently. And so that's why it's important, I think, to look at it as soon as possible, but it's a stretch, right? So let's see what we can make sense of and see what we can do. So for time t greater than or equal to 0 hours. So t is in hours. That's like a big deal. You got to keep track of these things now. Let r of t equals 80 quantity 1 minus e to the negative 15t squared represent the speed in kilometers per hour. So what do we know? We know t is in hours. Then we know that r of t, so r of t is speed in kilometers per hour. All right, so which car travels along a straight road? All right, the number of liters of gasoline used to travel X kilometers, there's a lot going on, to travel X kilometers is modeled by G of X. So R of T is in hours, R of T is speed in kilometers per hour. All right, so that's important. And then the number of liters of gasoline used to travel X kilometers is modeled by G of X. All right, so we got a lot going on. And ultimately, I'm going to use a calculator to solve a lot of this, but I'm going to start out by just writing it down because I think that it's easier to conceptually get it that way. So at what time? So this is a really common thing that they do on the free response questions, the FRQs, is they'll ask you a couple of questions that make you really think about the functions that you're given. So they're not even necessarily calculus problems exactly. They're more like, did you read type problems. So at what time does the car's speed reach 65 kilometers per hour? All right, so we know that R of t is speed, and we want to know at what time R of t equals 65. So we're actually just going to solve R of t equals 65. I'm going to do that on the calculator in a minute, and this will give me a t value. So t, and it's probably approximate. That'll give me a t value. I'm going to wait and do that after I've kind of read through the problem. So we'll go to the calculator in a minute. What is the average rate of change? Average rate of change, as soon as you see it, you should immediately think, what can I highlight this in? Average rate of change is algebra 1 slope. So that's algebra 1 slope. And you should be excited about that. So algebra 1, I think I'm going to capitalize the A in algebra. It seems respectful, you know. Okay, algebra 1 slope. What is the average rate of change of the car's speed? What is the algebra 1 slope of the car's speed function on the time interval from 0 to 5? Indicate units of measure. Okay, so speed is given by R of t, right? So R of t is speed. So we just need the algebra 1 slope of that. So that's going to be R of 5 minus R of 0 over 5 minus 0. That'll be an approximation. And then we want to give units of measure. So speed should be in kilometers per hour, right? So if you think about it, what you're doing is speed in average rate of change, I'm sorry, of the speed. So you know what, we'll work that out after the calculator section, after I start punching things into a calculator, which is going to be soon, because the next question, how much gasoline does a car use to travel 1,000 kilometers? So if we're traveling kilometers, the number of liters is going to be G of whatever. So this actually, we just have to find G of 1,000, right? So if I take 1,000 kilometers, plug it into G, it'll tell me the number of liters of gasoline used. So this is just going to be G of 1,000. All right, so I'm going to switch over to the calculator and punch these in so that we can get answers and start thinking about units on our answers. So this is probably not the best way to do this. You probably should do each one individually, but I wanted to, for whatever reason, I decided that I wanted to run through and write down values first. All right, so let's see. I need to define things. So R of t is going to be 80. You don't need multiplication here. I'm going to put it just to get in the habit, right? 1 minus, you should use the e to the x key, which is over here on the left column, of negative 15t squared. And then press enter and look at it and see if it looks like what it looked like in the notes. 80 quantity 1 minus e to the negative 15t squared. It does. Good. Okay, and then g of x is also something we want to define. So 0.07 x. This multiplication is not optional, and that's part of why you want to get in the habit of putting it in. 1 minus e to the negative x over 3. Press enter, look at it, see if it looks like it looked in the notes, which I think it does. All right, so we needed to solve, so that's menu 3.1, menu 3.1. R of t equals 65, which you could all, get in there, equals 65 for t. You can also solve this graphically. So if you want to solve it graphically, let me first, I'm going to write this in so that when I go back to the notes, you'll be able to see, but 0.334, and then that'll be hours. Okay, so you can also solve that graphically if you want or prefer or need to. So what you would do is add a graph page, and then you're going to graph R of X, not R of T. If you try to graph R of T, it'll ask if you want to create a slider. And that's usually, in my mind, that's just the indication that you're doing something wrong. You're trying to use the wrong variable, basically. So this is our thing. And then let me change the window. So I got to zoom like way out. Zoom out, zoom out, zoom out. Well, this function is just gone. Here, let me try to get a good window settings. I'm gonna go like 0 to, I don't know, 3, 5, I guess at some point I need. Let's go. All right, so I mean, this seems like it could be reasonable. Wow, speed, does the speed just increase like forever? Oh, and now this is crashed, and that's not great. Oh, we're back. Okay, so look at that, your speed. So you like get up to a certain speed and then you keep it forever. And then if I put in 65, so what I want to do is find the intersection. Menu 814. So here and here, and there you go. So 0.334. You get the same answer either way. It's just you have to know both methods because you're not sure if your calculator is going to be able to deal with solve. So it's really important that you know how to do both. So that's one of them. I also needed to do R of 5 minus R of 0 over 5 minus 0. I want a decimal. Oh, wow. Is that exactly 16? Ooh, that is not exactly 16. Is it? I mean, it must round it. Wow, it's so close to 16, which like kind of makes sense because the e to the negative, like if I expand this, the 16 over e to the 375 is basically 0. So I'm going to say that this is, it's approximately 16. Talk about units when we go back to the written notes. And then I needed to find g of 1000. I want a decimal of 70. Is it exactly 7? What is happening here? This is like as close to 70 as you can get. So I'm still going to say approximately 70 because it's not definitely 70. But it's very close, like so close the calculator can't do anything else. All right, let's go back to the notes and talk about some units on these things. Whoa. I accidentally scrolled like 5 pages when I did that. Okay, so at what time? So time is measured in hours in this problem, which is why I decided to go with hours on my units here, which makes sense. Average rate of change. So average rate of change, you're going to get the units of the function divided by the units of the input of the function, right? So if R of t is in kilometers per hour, right? So I put a check mark there, but my face was in the way. So this is in kilometers per hour. And then t is measured in hours. So there's 2 ways you can write this. You can write it as kilometers per hour squared, or you can say it's kilometers per hour and then just write per hour, which it's way easier to interpret that. So I actually prefer to write kilometers per hour. But if you've taken like physics or whatever, you're obsessed with simplifying those units, and there's almost nothing I can do to stop you. I wish I could. So I think those are our units there. How much gasoline? Well, what is gasoline measured in this problem? So in this problem, gasoline is measured in liters. So we're going to go with liters on this. So liters. All right. So I think what I'll actually do is maybe cut this video here, come back in the next video, and try to finish this off. So I will see you in the next video when we just keep going. So hope you find these helpful.